Okay, Module 5, Lesson 3, or lesson objective is I will be able to compose and decompose right rectangular prisms using layers and determine the volume of a rectangular prism. Essential question, how can I learn to compose and decompose right rectangular prisms using layers? The two standards we're working with today is MAFS 5 MD33, and basically this is recognize volume as a attribute of solid figures and understand concepts of volume of measurement. That's the basic part. Now the MD34 says measures volumes by counting cubes using cubic centimeters, cubic inches, cubic feet, and improvised units. Okay, so we're getting to the point where we're starting to count volume. So let's see what we're going to do today. All right, first off, the volume formula. Now you always hear them say, and it'll be on your sheet, that volume, which stands for V, equals length times width times height. Okay, so if you take the length times the width times the height, you will sit there and get the volume of how much it can contain. Okay, now volume can also be found by finding what they call the area of one face. So if you notice here, area, length times width, that would be the area squared. Okay, so if I had a figure and I had the length and the width, let's say I have this right here. Okay, I'll draw a quick little cube. Okay, like this here would be my length, and this here would be my width. If I multiply those two together, I get how much of the floor it covers, just like an area model. So let's say that was a 2 by 2, so it'd be 4 squared. Okay. Now, once we have that just on any side, we have that area of one side. If we multiply that by the height, or what we're going to be talking about today, the layers, we'll be able to know what the exact volume is. Because the height, we're just saying how many floors. So this area squared would be the area of the first floor, and the height would be how many floors. Okay, so let's give this a try. First, let's take a look at this. Notice what we have is we have one layer. Okay, so I'm coming up over here. I'm going to say I have one layer. Now, it says number of cubes in each layer. Well, let's see if I have one. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 cubes. Now, I could have also gone, I know that 3, and that's 4 wide. So 3 times 4 would got me 12. So since they are centimeters, I would end up with centimeters cubed, squared. Okay. So that would give me the area. Now, since this is one layer, and if I multiplied like we talked about in the previous one, because volume equals length times width times height, we know the length was 3, the width was 4, and the height was only one floor. So we come up with 3 times 4 is 12, times 1 gives us 12. So this first layer has not only an area of 12 centimeters squared, it has a volume of 12 cubic centimeters. All right. Now what happens if we put another layer on? Well, let's try. Now you can see we have one layer here, and we have a second layer here. So we have 2 layers. Now each layer still contains 12 cubes. So 2 times 12 gives us 24 centimeters cubed. All right, what about another layer? What if we were to add a third layer in there? Well, the third layer, each layer still has 12 cubes. So we can see that since it has 12 cubes, the total volume of this would have been 36 centimeters cubed. All right, so on this example, we went from the bottom and we started adding layers to the top of it. Now, that's not the only way you can do it, though. Oh, what if we had 4? What is that going to be? Well, we can extend it down here. Now we have 4 layers, 12 in each, and you're right, 48 centimeters cubed. Now let's try the other way. Notice this time, my layer is not on the floor, but it's on the side. Does that make a difference? Well, let's see. We still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 1 layer, 12 in each layer, and that's 12 cubic centimeters. Now, let's add a second layer, but this time we're adding a layer to the side. Now we have 2 layers. That's been 12. Still has 12 in each layer. So now we have 24 cubic centimeters. Excuse me. All right, let's continue on. Let's add a third layer. And there's still 12 in each one. So there's 1, 2, 3 layers times 12 gives us 36 cubic units. All right, so what we're basically trying to show here is that no matter whether I have a volume cube like this, and if I split it up in layers vertically or horizontally, like so, if I find the area of one layer and multiply that by the number of layers, I will be able to find how many cubic centimeters. In the same way, let's say that instead of it being split up that way, we split it up this way. As long as I find out what the area of that layer is and multiply that by the number of layers, I can find the volume that way also. Okay, so as long as you find the area of one face and multiply that by how many layers are in that cuboid, then you can find the area. Okay, now we're going to be doing this in the classroom. You're actually going to be making little boxes again and filling them full of cubes. Okay, so you'll get some hands-on on it, but basically remember you're working with the layers, not the individual cubes this time. All right, see you in class.